Hello. So today we're looking at parent functions. Parent functions. What are parent functions? All right. Well, let's see what they're asking us to do. Sketch the graph for the following parent functions. All right. Parent function. So what's a parent function? A parent function is a function or a mapping function that has no transformations applied to it. So it's almost like the most basic bare minimum function or function. So for example, this is a good example. The first one, y equals x. So what does that look like? So let's graph this. We'll just draw some, all right, why don't we use black for our axes? So what kind of function is this? This is a line. So it has the form y equals mx plus b. Y equals mx plus b. So this is the form of a line that we all know, except b equals 0 and m equals 1. So it's the most basic line that we can find. Y equals x. And what does a line look like? Let's use a color. This particular line has y-intercept 0, x-intercept 0, and slope of 1. So it looks like this. Very, very simple. It goes through the origin. So that's our parent function for lines. Let's label that A. All right, now let's look at B. All right, let's scroll over. Oh, looks like we might run out of space. All right, again, let's draw some axes in here. There, good. And now let's try and graph this. Okay, so when x equals 0, y equals 0. When x equals 4, y equals 2. When x equals 9, y equals 3. It kind of looks like that. Looks like that a little bit. And that's our parent function for any square root function that we might have. Y equals square root of x. Good. All right, let's have a look at C. Okay, I'm going to scroll over. We have some space. Let's draw some axes in. We have something to work with. Let's put it here. Good. Okay, let's pick a color for our graph. This pink. Okay, so y equals 1 over x. So as x gets very large, this value is going to tend to 0. However, when x gets very large, positively, we're going to be above 0. When x gets very large negatively, we're going to be below 0 or a negative value of y. Now, as x gets very small, so as it approaches 0, y is going to get very big, but in which direction? So as x gets very large, very small, or heads towards 0 from the positive direction, y is going to be very big positively. And when x heads towards 0 from the negative direction, y is going to get very small negatively. So our function ends up looking something like this. So we'll learn, or you probably learn about, we'll talk about asymptotes later, but we have two asymptotes here. We have the line, the x-axis is an asymptote and the y-axis is an asymptote. So an asymptote is a line that your function gets very, very close to, but never crosses. All right, so this is our function, y equals 1 over x. So we have an inverse function. And we will see transformations of this function later. Okay, so now let's go over onto this side and look at part D. So y equals x squared. So I think everyone knows what this is. This is a quadratic or parabola. So let's draw our axes and let's draw our parabola. Let's We have axes. So let's pick a color. How about yellow? This is D. Okay, so x squared. So we know what a parabola looks like. It kind of looks like a bowl. So when x equals 0, y equals 0. So the vertex is right at the origin. It's opening upwards because if we take the square of any number, we're going to have a positive value for y. So our y values are negative, never negative. It looks something like this. So y equals x squared. Again, the most basic parabola that we learn about. And finally, let's go over to this side. Let's look at E. E is y equals 2 to the power x. So why don't we do that up here? Again, let's draw some axes in. Actually, we can just scroll over here. Okay. All right, and this is E, y equals 2 to the x. All right, so let's take a look at this. One nice way of graphing is to consider a table of values if you don't know what the function looks like. So why don't we do that? So when x equals 0, y equals 1. When x equals 1, y equals 2. When x equals 2, y equals 4. When x equals negative 1, y equals 1/2. When x equals negative 2, y equals 1 over a quarter. Okay, so that's interesting. So now let's see if this is enough information to graph our function or get a sense of what it looks like. So when x equals 1, when x equals 0, y equals 1. When x equals 1, y equals 2. When x equals 2, y equals 4. Okay, so that's on the positive side, so it's increasing. X equals negative 1, we get a half. When x equals negative 2, we have a quarter. So it looks like it's getting closer and closer to the x-axis, but it's not crossing it. So we join these dots with a nice smooth curve. All right, so it looks like we have an asymptote, a horizontal asymptote. That is the x-axis. And then as your values of x get larger positively, the function goes off to infinity. So this is our exponential function or a parent function. Parent function of our exponential functions of the form 2 to the power x. Good. Okay, so that takes care of some of the parent functions. Now let's see what we have. Our second question's asking us. Let's zoom in a little bit. For the following functions, identify the parent function. Okay, so we've seen a few already. So let's see if we can identify them when we're given transformations. All right, so part A, what do we have here? We have 4 over x minus 1 plus 2. So let's consider where the variable is. Our variable x is in the denominator. So we scroll back up. We're kind of in this situation in part C. So our parent function is probably 1 over x. So let's go back down and we'll put our parent function is 1 over x. Okay, part B. Y equals negative 1/2 in brackets x plus 1 squared plus 4. Okay, so we have something squared. Let's go look at some of the parent functions we saw in the first question and see if any of them have like a square or a power attached to our variables or our independent variables raised to some power. And the one function that we see like that is the one in D, so y equals x squared. So good high probability that our parent function for part B is y equals x squared. All right, so part C. Part C, our function is y equals 2 to the power negative 3x plus 4 all plus 5. So where is our x? Our x is in the exponent. The base of that exponent is 2. So let's go back up and let's look at our parent functions given in the first question. And do any of them look like there's a number in the base? and the exponent is a variable. And it looks like part C. So it looks like our parent function is y equals 2 to the power x. Oh, now part D. What is our function? Y equals the square root of 4x plus 3, all minus 1. Okay, so where's our x? Our x is under the square root sign. If we go back up, first question, which of our parent functions have our x under a square root? Our parent function part B, y equals the square root of x. So this is our parent function, y equals the square root of x. Good, part E. Interesting. So y equals 1/2 of, in brackets, x minus 1 cubed. Okay, so where's our x? Our x is in the brackets and it's being raised to the exponent 3. So if we go back up, the first question, do we have any parent functions that are a variable raised to a power? We do. Part D, however, the power is 2. So if we go back to our question, our exponent is 3, so our variable, independent variable x is raised to the power 3. So our parent function is probably going to be that independent variable x raised to that exponent, which is 3. And last one, f. Y equals 5 times, in brackets, x plus 2 minus 6. So let's scroll back up. Is there any parent function in the first question that is just an x raised to just the power 1? That's our basic line in part A. So our parent function, we go back down, our parent function is y equals x. Good. So it looks like we've finished. And we have identified parent functions. We've drawn them and identified them. This brings us to the end of our session. If you have any questions, send us a note at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we'll see you soon.